the law of sines and the law of cosines is something that we're going to be able to, we're going to need to use the law of sines and the law of cosines to be able to find missing pieces of triangles. You say, well, we've already learned lots of ways to do that. Yes, but we've always learned on triangles that were right triangles, not any triangle, period. We're going to learn today about the law of sines, which is really a tool to use with non-right triangles. The law of sines is basically a way of finding side length and angle measurements inside non-right triangles. And you see the formula there, A over sine A equals B over sine B equals C over sine C. Well, that's not a three-part formula. It just means that I can use any of the sides and angles to kind of set up a ratio, a proportion. So I'm going to pick two of those, and you'll see in a minute when we do the example exactly what I mean. You'll never use all three of them at the same time. So we're going to take this and use a short example. This is actually right out of your book. So we'll look at the first part. In this example, they give me a triangle, an obtuse triangle, clearly not a right triangle. They give me angle B, which is 28.7. They give me angle C, which is 102.3, and side length B, which is 27.4. This is in a AAS scenario. We've got an angle, an adjacent angle, and then an adjacent side. So in that order, it's AAS. And I need to find the missing pieces. So I need an angle A, I need a side length A, and I need a side length C. The very first and easiest thing, anytime you have a double angle situation, where I know two of them, finding the third angle is always the first and easiest thing to do. That means I'm going to add up the two other angles, subtract them from 180. In this case, I'm going to have an angle which is 49 degrees. Okay. To find the side lengths, not so easy. I don't really have a quick and easy way to do this. We were going to use the law of sines. So what I'm going to do first is I'm going to identify which pair of side and angle do I have. Well, we have B, which is 27.4, side length B, and we have angle B, which is 28.7. So I'm going to set up my problem. I'm going to find side length A first, because I just figured out the angle A. I could have done C first. These two parts could be done interchangeably because it doesn't really matter. I've got a proportion. I'm going to cross multiply. So we have A equals 27.4 times the sine of 49. So basically I multiplied by sine of 49 on both sides. I simplified that value first and then divided to make sure I didn't make any careless mistakes. And that turns out to be 43.06 feet for side length A. If we come down and we look at the next one, I need to define side length C. So I figured out what angle C was, which was given to me. I set it up like this: C over sine C equals, and I just left this as the same. It's to your advantage to use the numbers that they give you over the ones that you calculate, unless you absolutely have to. This way, if you have a careless mistake in your own calculations, it won't filter through and cause all the rest of your pieces to be incorrect as well. And this is the same exact kind of process. We'll work through that. This one allows me to do basically the same exact operation, except the numbers are different. I have a sine of 102.3. Work that out. You multiply both sides by that. You get 26.77 divided by 0.4802. This time it gives me 55.75 feet as side length C. Now, one thing when you finish, you want to make sure that your triangle makes sense. Okay, triangles are proportional, so that means that if you have a very large angle, then the side length opposite that angle is going to match up with it. In other words, it's going to be the longest side. And you can see that angle C is the largest angle in my triangle, and side length C should be, once I've calculated it, should be the longest side. And of course, 27.4 is B, 43.06 is A, and C is 55.75. So that means that A, C is definitely the longest side, and B is the shortest side, which matches with the smallest angle for B as well. Always take a few seconds and just make sure it makes sense. That'll save you a lot of careless mistakes if you're like, oh, wait a minute. I've got the longest side with the smallest angle, and that absolutely doesn't work. One other thing I want to talk about is when do you use the law of sines? We haven't talked about the law of cosines yet, but on the quiz, we are going to have a quiz in a few days, and I'm going to just simply give you a problem, and I'm going to say solve the triangle, find the missing pieces. I'm not going to tell you which one to use, and you're going to have to decide on your own. So there's a couple of technical ways of what you have. For example, AAS or ASA or SSA, that's right, SSA, are the times when we're going to use the law of sines. Now, the SSA situation, this is called the ambiguous case of sines because it's ambiguous to what the triangle looks like. In fact, you could draw two, maybe one, or possibly no triangles with that configuration. And so it's very dangerous to do that without actually looking and trying it to make sure that you've got the right situation. So we'll talk about that one in a later tutorial. Okay, but bottom line, if I have a matching pair, in other words, in this problem we had side length B and angle B. If I have a matching pair, automatically I can use the law of sines. If I don't, then I'm going to be using the law of cosines. Now, one thing to note is that if you have a right triangle, if one of your angles happens to be 90 degrees, well, then you're back in the old way, and you can use the Pythagorean theorem. You can use traditional sine, cosine, and tangent, basic stuff like that. Don't let those. Sometimes we like to just slip one of those in and say, here's a right triangle. And I'll grant you that law of sines was going to work, but it's a whole lot more work than you need to be doing. So watch out for that. Make sure that you go through this and know what to do when you're given a law of sines scenario.